Good morning students. Session 2, grade 11 maths, chapter 1, sets, relations and functions. In last class we have discussed what is set, types of set, representation of a set. So we are having three types of representation of a set: descriptive form, set builder form, roster form. And we have discussed about the Cartesian product of two sets also, and we started doing the sums on the exercise. And at last we did first division of the fourth sum, and I gave second and third as homework for you. Hope you all did. Now we are going to continue the fourth division of the fourth sum of the exercise 1.1. So for any sets A, B, C, so we can take according to our wish A, B, C. So now we can take A is equal to 1, 2, 3. Simple set we can take. B 3 and 5, and C is equal to 1, 3, 5. And it is given that C difference, B difference A is equal to C intersection A union C intersection B dash. So here this complement is also we have to find. So to find complement, we are in need of universal set also. So universal set also we have to take. So universal set is a set which contains all the elements of all the sets. So we have to take all the elements. That 1, 2, 3, 4 is not there, and 5. 1, 2, 3, 5 is there. Is it clear? Right. Now we have to go with the sum. So LHS. What is LHS? Kana? C difference, B difference A. So bracket term should be evaluated at first. So we have to find B difference A at first. So B difference A. What is B kana? B is nothing but 3, 5, and A is nothing but 1, 2, 3. So what is B difference A? Set of elements in B not in A. So we have to consider the elements of B which are not in A. So 3 is here. 3 is also there in A, so we have to strike out. And 5 is here, 5 is not in A, therefore 5 will come. So this is B difference A. Next we have to find C difference, B difference A. What is C kana? C is nothing but 1, 3, 5. Difference. And B difference A is, what is B difference A, which is nothing but 5. So we have to calculate the elements of C not in B difference A. So we have to find out the elements. So what are the elements here we are having? So C difference, B difference A is equal to, so 1 is here, 1 is not there, therefore 1 will come. 3 is here, 3 is not there, therefore 3 will come. So 5 is here, 5 also there, therefore 5 we have to strike out. So elements of C not in B difference A. So this is the element 1, 3. So let it be equation number 1. Next we move on to RHS. What is RHS kana? C intersection A union C intersection B dash. So first we will find B dash. So what is B dash kana? B dash is nothing but set of all elements in U not in B. So what is U? 1, 2, 3, 5. Difference. What is B kana? 3, 5. So we have to list out the elements of U not in B. That is, 1 is there, 1 is not there. 2 also will come. 3 and 5 will not come because 3 and 5 is there in B. So this is B dash. Next we have to calculate C intersection A. That is C intersection A. That is common elements both in C and A. This is C and this is A. What are the common elements? 1 is there, 3 is there, and 5 is there. So 1, 3. So is C intersection A. Is it clear? Right. Next we have to find C intersection B dash. So C intersection B dash we have to find. So what is C? 1, 3, 5 is there. B dash is 1, 2. What is the common element? So 1 is the common element. So 1 only will come. So 1. So now C intersection A union C intersection B dash. So now we have to take union of 1, 3 and 1. So what is the element? 1 and 3 will come. This is the equation number 2. From 1 and 2, what do you observe there? From 1 and 2, C difference, B difference A equal to C intersection A union C intersection B dash, hence verified. So here 5th and 6th division is there, that is homework for you. Okay, Kana. So we are having division 5 and 6 in 4th sum, that you can do as a homework. So with the sets what we have taken already, or with new set of sets you can take. So we have to prove B difference A intersection C is equal to B intersection C difference A, which is also equal to B intersection C difference A. So we have to find this one, it will be equation number 1. We have to find this one, it will be equation number 2. And this is the equation number 3. From 1, 2 and 3, we have to equate all the 3. Is it clear, right? Next, B difference A union C is equal to B union C difference A difference C. These things you have to do as a homework with the sets what we have taken already by doing for doing 1 to 4, or you can take new set of 3 sets to do. Is it clear? You try it. Next, we move on to example 1.3. So A union B dash union C intersection A intersection B dash intersection C dash union A union B union C dash intersection B dash intersection C dash, which is equal to B dash intersection C dash. This is what we have to prove. So without taking sets we have to prove this. So by argument you have to prove. So how we have to do by argument? So can we recall the definitions of union and intersection? Yes. When you are taking union of two sets, what you are going to do exactly? So we are going to combine the elements of A and B together. Obviously, which is a big set when it is compared with A and B, because we are going to combine the elements of A and B together. So when you are combining, you will get much more elements than A and B. So when you are taking union, you will get a big set. That is the result that you have to keep in your mind. When you are taking union, you will get what? Big set, right? When you are taking intersection, so we are taking A intersection B. That means we are going to collect the common elements which are both in A and B. So obviously it will be a small set, because few elements only will be common in A and B, or equal number, same elements will be common. So if A is having 5 elements and B is having 5 elements, if all the elements are common, we can take only 5 elements. It will not exceed the number of elements of A and B. Is it clear? So union means you will get a big set. While you are taking intersection, you will get small set. Is it clear? So these things is enough to do this sum. Is it clear? So what are the things? When you are taking union, you will get a big set. When you are taking intersection, you will get a small set. So this is the idea of doing this sum. Is it clear? Shall we do? So now prove. So we can take this A union B dash union C intersection A intersection B intersection C. So first we find the first thing only. So what is this, Kana? Tell me. A union B dash union C intersection A intersection B dash intersection C dash. So we are taking intersection. So intersection means what you will get exactly? You will get a small set. So here we are having union. So it will be a big set. Here we are taking intersection. It will be a small set. When you are taking intersection, what will be the result? The result will be the small set. So you will get this one. That is A intersection B dash intersection C dash. This is the answer. Is it clear, Kana? So this will be the union and this will be the intersection. So union is a big set and intersection is a small set. While you are taking intersection for these two sets, you will get definitely a small set as the answer, because we are taking what? Intersection here. So first one is over. So next we move on to the second thing. What is the second thing? A intersection B union C dash. So A union B union C dash intersection B dash intersection C. So this is what we have to find out. So here, which one is small set and which one is big set? So here we are taking union. So obviously this is big set. So here we are taking what? Intersection. Obviously it will be a small set. So now what we have to take? We are going to take intersection. So while you are taking intersection, whether you will get a big set or small set, obviously you will get small set. So which one is the answer? B dash intersection C dash is the answer. Is it clear? Right. So now we have to combine two sets. We are going to take union of these two sets. That is, so we got two results. Now we are going to combine this. That is A union B dash union C intersection A intersection B dash intersection C dash union A union B union C dash intersection B dash intersection C dash. So now we have to find this. What is this, Kana? A union B dash union C intersection A intersection B dash intersection C dash is nothing but what? A intersection B dash intersection C dash. So we are getting intersection. The small set is the answer. What is the answer, Kana? A intersection B dash intersection C dash. You have to take union with this set. What is the answer of this one? A union B union C dash intersection B dash intersection C dash is nothing but a B dash intersection C dash. That is B dash intersection C dash. So small set. So now we are going to take what? Union. So we are going to take what? Union. So union means we will get what? Small set or big set. So we will get obviously big set only will get. So here both are intersection. So we have to decide which one is a big set and which one is a small set. So we are taking intersection of three sets. So here we are taking intersection of only two sets. So we are intersection of two sets means we are collecting the elements of common elements of two sets only. So it is little bigger. When you are collecting the common elements of three sets, you will get obviously a small set. Is it clear? So here we are collecting the common elements of three sets. Here we are collecting the common elements of only two sets. So obviously it will be the big set. So when you are taking union, what will be the answer? Of course the big set is the answer. So what is the big set, Kana? B dash intersection C dash hence 2. Is it clear? So by argument only we have proved this. So the two things are necessary to do this sum. So when you are taking union, you will get a big set. When you are taking intersection, you will get a small set. In this concept, we did this sum. Okay, Kana. Next we move on to example 1.1. So A is equal to set of all x such that x is equal to 4n plus 1, 2 less than or equal to n less than or equal to 5, n is the natural number. We have to find the number of subset that A will have. So what do you mean by number of subset? It's nothing but number of sets in the power set of A. That is n of P of A only we have to find. What we have to find? N of P of A. So what is n of P of A? The number of elements in the power set of A. What do you mean by power set of A? The set of all subsets of A. So that is what we have to find. So before finding, we must know the formula. N of P of A is equal to what? 2 power n of A. N of P is equal to what? 2 power n of A. N of A is nothing but number of elements in the set A. So first of all, we have to find the number of elements of the set A. So we have to generate the elements of A. So A is equal to set of all x. So x is equal to 4n plus 1, 2 less than or equal to n, less than or equal to 5. So first we have to take 2. So 4 2s are 8, 8 plus 1 is 9. So 3 we can take, 4 3s are 12, 12 plus 1 is 13. 4 we can take, 4 4s are 16, 16 plus 1, 17. Next 5 we can take, 4 5s are 20, 20 plus 1, 21. So up to 5 only we have to take. So how many elements are there? 1, 2, 3, 4 elements are there. Therefore, here n of A is equal to 4. So which implies n of P of A is equal to 2 power n of A, which is equal to 2 power 4. What is 2 power 4? Kana? 2 into 2 into 2 into 2. 2 2s are 4, 4 4s are 16. Therefore, number of subsets of A is equal to 16. Therefore, the set A has how many subsets? 16 subset it will have. Is it clear, Kana? Okay, Kana. Next we move on to example 1.5. So in which n of B difference A equal to 2 into n of A difference B equal to 4 into n of A intersection B. and we have to find n of p of a. That is number of elements in the power set of a. That is number of subset that a has. This is nothing but 2 power n of a. So we have to find this. We are in need of what? 2 power n of a only. We have to find that is n of a. If we know n of a, we will find 2 power n of a. Is it clear? So with this, we have to find n of a only. So this is the given statement. Shall we take, let n of a intersection b is equal to k. Let me take this as k. So what it will become? So it implies n of b difference a is equal to 2 into n of a difference b is equal to 4 into this is k. 4k. So by equating this one, we will get n of b difference a is equal to 4k. And by equating this one, we can cancel 2 2s are 4. 2 times it will come. Therefore, n of a difference b equal to what? 2k. So here, you look at this Venn diagram. This is A, this is B, and this is of course A intersection B. So this is A only, that is A difference B. This is B only, that is B difference A. So is it clear? So now I am going to find now n of A union B. So this n of A union B means we have to combine both elements of A and B. So n of A union B means n of A difference B plus n of A intersection B plus n of B difference A. Is it clear, Kana? So A union B means we are going to combine both elements. This is A difference B, this only. It is A intersection B, and this only comes for B difference A. So now we are going to combine A union B, that is n of A union B equal to n of A difference B plus n of A intersection B plus n of B difference A. So and it is given n of A intersection B is equal to 14. So this is also given n of A intersection B is equal to what? 14. Now n of A difference B. What is the n of A difference B? N of A difference B is 2k. N of A intersection B. N of A intersection B is k. N of B difference A is nothing but 4k. Is it clear? So 14 is equal to 7k. So it implies k is equal to what? 2. So we got k is equal to 2. Now we have to find only what? N of A. So now n of A. So n of A only we have to find. So n of A is nothing but union of A difference B and A intersection B. That is n of A difference B plus n of A intersection B. That is n of A is equal to n of A difference B plus n of A intersection B. So what is n of A difference B? N of A difference B is nothing but 2k. What is k, Kana? K is equal to 2. So therefore we can have 2k plus A intersection B. A intersection B is k. So we will have 3k. So k is nothing but 2. So therefore 3 into 2 which is equal to what? 6. Therefore n of A is equal to what, Kana? 6. So what we have to find? We have to find n of P of A. That is n of P of A, which is equal to 2 power n of A. So which is equal to 2 power 6. 2 power 6 means 2 into 2 into 2, 6 times we have to multiply. 2 2s are 4, 4 4s are 16, 16 4s are 64 will come. Therefore, number of subsets of capital A, that is n of P of A is equal to 64. That's it. Okay, now next we move on to example 1.4, which is of course a different sum. So in which if x is equal to 1 2 3 etc 10 and A is equal to 1 2 3 4 5 and find the number of subsets of B, subset of X, such that A difference B is equal to 4. We have to find number of subsets that B has. Is it clear? Right. So we have to form the set B to find out the number of sets. Is it clear? So the clue, what is the clue? A difference B is equal to 4. So with this clue, we have to frame the set B. Shall we write let B is equal to, we have to find the elements of B. So A difference B is equal to 4. What it means? Set of elements of A not in B is 4. That is 4 will not come in B. So clearly 4 will not come in B. So and all the elements of A except the elements in B is A difference B. So therefore B contains all the elements of A except this 4. Is it clear? So B contains all the elements of A except this 4. So probably B may contain 1, 2, 3, 5. So this is the element that B has, the minimum element that B can have. Is it clear? Because A difference B is equal to 4. Shall we compare this? 1 is here, 1 is there, so we will cancel off. 2 is there, 2 is here, we can cancel off. 3 also we can cancel. 4 is here and 4 will not come here, therefore 4 comes in A difference B. 5 is there, we can cancel off. Is it clear, Kanam? So this is the minimum element that B contains. Is it clear? So apart from this element, B can have much more elements. Is it clear? So we have to find that elements. Is it clear? So shall we include the set C? C for every subset of C, subset C of, so B can have much more elements other than in 5. So after 5 we can have 6, 7, 8, 9, 10. So a subset of this set is considered as C. By unioning the C with this 1, 2, 3, 5, we can have a set B. Is it clear? Therefore here we have to find number of subsets of B. Number of subsets of B which is equal to, so if C is having 2 sets, with it we can form 2 sets for B. If C is having 5 sets, we can form 5 B sets. If C is having 10 sets, so we can form 10 different sets for B. Is it clear? So we can find number of subsets of B according to the number of subsets of C. So the number of subsets of B is equal to number of subsets of C. So C is a subset of 6, 7, 8, 9, 10. Therefore, the number of subsets of C is nothing but number of subsets of 6, 7, 8, 9, 10. Therefore, number of subsets of B is nothing but number of subsets of 6, 7, 8, 9, 10. Is it clear? So apart from this 1, 2, 3, 5, B can include some elements of 6, 7, 8, 9, 10. Is it clear? So B can have 6, or B can have 6, 7, 8, or B can have 6, 7, 8, 9, 10. Is it clear? Right. Now the number of subset of B is equal to number of subset of 6, 7, 8, 9, 10. So how many elements are there? You can count 1, 2, 3, 4, 5 elements are there. Therefore number of subset is nothing but 2 power 5. 2 power 5 is nothing but 2 into 2, 2 into 2 into 2. 2 2s are 4, 4 4s are 16 into 2. It will become 32. So therefore number of subsets of B is nothing but 32. With the condition A difference B is equal to what? 4. So 4 will not come in B. Is it clear? So with this we can form this set. So apart from this element, B can have much more elements other than this 1, 2, 3, 5. That elements should be fine without doubt. So that is depends upon the value of C. So C is a subset of 6, 7, 8, 9, 10. So we are having 5 elements. Therefore 2 power 5 subset we can form. Is it clear? Right. Next we move on to example 1.6, and we have 2 sets A and B, and the number of elements of the set A and B is nothing but M and K. That is, let A and B are 2 sets with N of A is equal to M and N of B is equal to K, and first set have more number of elements, that is M is greater than K, and it is given that the first set has number of subsets, that is 112 more than the number of subsets of the second one. That is, what is that? N of, that is 2 power M, that is number of subsets of set A, minus 2 power number of subsets of capital B is equal to 112. That is, first set have 112 more subsets than the second set. Is it clear? Right. But therefore, number of subsets of A is nothing but 2 power m. Number of subsets of B is nothing but 2 power k. So their difference is given as 112. So now 2 power k is taken as a common because m is greater than k. So k is taken. What else will come? 2 power m minus k minus 1 is equal to 112 can be written as 112. 2 we can put 5 2s are 10, 6 2s are 12. 2 again we can put 2 2s are 4, 8 2s are 16. 2 again we can put 1 2 is 2, 4 2s are 2. Again we can put 7. Therefore 2 power 4 into 7. So this can be written as 2 power k into 2 power m minus k minus 2, which is equal to 2 power 4 into this 7 can be written as 8 minus 1 because we are having minus 1 no. So for that we can split it. So 2 power 4 into this 8 can be written as 2 power 3 minus 1. Therefore 2 power k into 2 power m minus k minus 1. So with this k is equal to what? 4, which implies k is equal to 4 and m minus k equal to 3. So with this m is equal to 3 plus k. What is k? 4. So this is equal to 7. Therefore number of elements in the set, first set A is 7. Therefore n of A is equal to 7 and n of B is equal to 4. Is it clear? That's it. Okay, next we go on to sixth sum of the exercise 1.1. So given n of P of A equal to 1024, n of A will be equal to 15, n of P of B is equal to 32. So number of power set of A, number of power set of B is given and number of elements in A unit B is given. We have to find number of elements in A intersection B. Is it clear? So with this n of P of A we have to find n of A. So now, so here what is it? N of P of A which is equal to 1024 and n of P of B which is equal to 32. So what is n of P of A? Is nothing but 2 power n of A. 2 power n of A is equal to 1024 can be written as 2 power. So 1024. So 2 power we have to write 2 into 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 16, 16 2s are 32. So 32 into 32 is nothing but 4, 6, 6, 9, 1024. So how many times? 10 times will come. 10 times will come. Therefore 2 power 10. So with this n of A is equal to what? 10. So we got n of A. So with this we have to find n of P of A is nothing but 2 power n of B, which is nothing but 32. How many times? 2, 4, 5 times. So 2 power 5 times. So which implies n of B is equal to 5. So we got n of A, n of B, n of A in B. With this we can find A intersection B easily. Is it clear? Right. We know that. We know the formula. So n of A union B is equal to n of A plus n of B minus n of A intersection B. Is it clear? So n of A union B is nothing but 15 equal to n of A is 10 plus n of B is 5 minus n of A intersection B only we have to find. So now we can take this n of A intersection B. N of A intersection B is equal to 10 plus 5 15. 15 minus 15 is equal to what? 0. Therefore n of A intersection B is equal to what? 0. That is A intersection B is a empty set. That is they are disjoint sets. Is it clear? Right. Next we move on to seventh sum of the exercise. It is given that n of A intersection B is equal to 3. N of A and B equal to 10. With this we have to find n of P of A symmetric difference B. So with this we have to find A symmetric difference B. So can we recall this formula for symmetric difference? Yes. A symmetric difference B is nothing but A difference B union B difference A. So this is the formula. So shall we go with the Venn diagram? So this is A, this is of course B, and this part only comes from A difference B, and this is B difference A, and this is of course A intersection B. So what we have to find? A symmetry difference B is nothing but A difference B union B difference A. So this is A symmetric difference B. So A symmetric difference B means union of A difference B and A B difference A. That is, in A union B, A intersection B will not come. So A difference B union B difference A is nothing but in A union B, A intersection B will not come. Is it clear? So here, and this can be written as, that is, now, so we can have the formula from this. That is, A symmetric difference B is nothing but A union B. A union B means full set will come. With this, what portion will not come? A intersection B only will not come. Is it clear? So A union B difference A intersection B. Is it clear? That is, N of A set difference B equal to N of A union B minus N of A intersection B. So here N of A union B is given that 10 minus A intersection B is nothing but 3. Therefore N of A symmetric difference B is equal to 7. So now which implies N of P of A symmetric difference B is equal to 2 power 7. 2 power 7 is nothing but 2 into 2 into 2 into 2 into 2 into 2 into 2. 2 2s are 4. 4 4s are 16. 16 4s are 64. 64 into 2, 128. Therefore, 128 elements are there in N of P of A difference B. That is the power set of A symmetric difference B. Contains 128 sets. That's it. Okay, students. Next we move on to 8th sum of the exercise 1.1. Given A cross A has 16 elements. Can we recall the set A cross A? That is the Cartesian product of A cross A. So A cross A is nothing but set of all A comma B such that both A comma B belongs to capital A. Set of all A comma B such that both A comma B belongs to capital A. That is, first element belongs to capital A and the second element is also belongs to capital A. So that is the Cartesian product of A cross A. Here A cross A contains how many elements? 6 elements, 16 elements. Is it clear? So 1, 3 and 0, 2 are the elements of A cross A. We have to find A. So now A is equal to. So 1, 3 is the element of A cross A. So that is A, B. So 1, 3 means both the elements are in A only. Is it clear? So therefore 1 is there in A, 3 is there in A, and 0 is also there in A, 2 is also there in A. So since these are the elements of A cross A, so the ordered pair, that is A comma B, that is A belongs to capital A and B is also belongs to capital A. So because of that rule, so these 4 elements are the elements of capital A, that is 0, 1, 2 and 3. So these are the 4 elements of capital A, that is N of A is equal to 4. And hence N of A cross A is equal to 4 into 4 will become what? 6. So this is the answer. Very simple sum. A cross A is given. With this we have to form A. So now we move on to 9th sum. N of A is equal to 3. That is A has 3 elements. N of B equal to 2. That is B has 2 elements. X, 1, Y, 2, Z, 1 are the elements of A cross A. Shall we recall A cross A cross B? A cross B. So A cross B is nothing but set upon A comma B such that small a belongs to capital A, small b belongs to capital B. That is the ordered pair. The first element should be the element of the capital A and the second element is the element of the capital B. So here X, 1, Y, 2, Z, 1 are the elements of A cross B. That is X, Y, Z are the elements of capital A. Is it clear? And the second element 1, 2 and 1 again is the element of capital B. So with this we have to find capital A and capital B. Is it clear? Very simple sum. So here capital A is equal to what are the elements of capital A? The first pair, the first element is called the element of capital A, that is X, Y, Z. So here N of A is equal to 3. So correct. So next we have to find the B set. So we say the elements of B we have to collect. The second element is the element of B. So 1 is here, 2 is here, 1 again comes. We know in a set, elements should not be repeated. Elements occur only once in the set. So 1 and 2 is there already. So no need to write again. So 1 and 2, there is 2 elements there. So this is the required capital A and capital B. Is it clear? Right. Next we move on to 10th sum. A cross A has 16 elements. Then what about A? A has 4 elements. Then only 4 into 4 will become 16. And S is a set of all A comma B such that it's a subset of, that is the element belongs to A cross A. The element of S is in A cross A. And where A less than B, the condition, one condition is there. This is important. What is the condition? A less than B, that is one element is paired with another element if the another element exceed the first element. Is it clear? Then only it will pair with the element. So minus 1 comma 2, 0 comma 1. So minus 1 pair with the 2, that is minus 2 is greater than minus 1. Here 1 is greater than 0. Then only it will pair along with the elements. And S is a set of all elements like A less than B. If A less than B, then that particular element is an element of S. So S is a subset of A cross A. Is it clear? Right. We have to find the remaining element of S. So 2 element of S is given. So with this we have to form the set capital A. So solution. Here we have to find the set capital A. A contains 4 elements we know. So A cross A has 16 elements. Hence A contains how many elements? 4 elements. So what are the 4 elements there? Here A has 4 elements. So now capital A is equal to, so minus 1. So both the elements belongs to capital A only. So minus 1, 0, 1, 2. We have to write in order. So for all the 4 elements came. So these are the 4 elements that A has. Now we have to find the remaining elements of S. Therefore, the remaining elements of S. So we have to pair along with A cross A. We have to find minus 1 comma 0 is there, not there. So we can write minus 1 comma 0 and minus 1 comma 1. Minus 1 comma 1 and minus 1 comma 2 comes. Minus 1 comma 2 already is there. So we are writing remaining elements only. So minus 1 comma 2 will not come. So next we have to take 0. If you are taking 0 now, you can pair along with 0 comma minus 1. 0 comma minus 1 will not come because A less than B. So higher element should be paired. So if you are taking 0, you can pair along with the 1 and 2 only. You should not come back. Is it clear? If you are coming back means you are paired along with the lesser element. Is it clear? So you have to go in a forward manner. If you are taking 0, you can have 0 comma 1. 0 comma 1 is already there. So therefore it should not come. 0 comma 2 will come. And if you are taking 1, you can't pair with 1 comma minus and 1 comma 0 will not come because A less than B. So you can pair along with the higher elements only. So you can pair 1 comma 2. So these are the 4 remaining elements of the set S. Is it clear, Kana? Once again I repeat. S is a set of all A comma B such that A comma B belongs to A cross A. That is, S is a subset of A cross A. So these are the elements of S. So the elements of S means this elements belongs to the set A. So minus 1 belongs to A, 2 belongs to A, 0 belongs to A, 1 belongs to A. Therefore A has 4 elements. Obviously since A cross A is equal to 16 elements, A has only 4 elements. So these are the 4 elements. So we have to find the remaining element of S. In S, we are having one condition. What is the condition? A less than B. So we have to pair along with the higher element only. We should not go with the lower element. We have to pair along with the higher element. If you are taking minus 1, you can pair along with minus 1 comma 0, minus 1 comma 1, minus 1 comma 2 only will come. So if you are taking 0, 0 comma 1, 0 comma 2 only will come. 0 comma minus 1 will not come. See, because if you are taking 0 comma minus 1 means, so which is 0 is greater than minus 1. So it should not come. Is it clear? So if you are taking 0, you have to go in a forward manner only. 0 comma 1, 0 comma 2. If you are taking 1, 1 comma 2 only you can pair. You should not pair along with 1 comma minus and 1 comma 0. Is it clear? So we got the 4 elements. Already 2 elements are there. So we are asked to find only the remaining elements of S. So that's it. So with this I conclude my session. Before conclusion, so 2 sums are left. That is the example 1.8, in which you have to find n of A union B cross A intersection B cross A set difference B. A and B is given. So you can find A union B, A intersection B, A symmetric difference B. So with this you can find n of the number of elements in the set. With that you can calculate. So you have to product all the elements. And sum number 5, justify the truthness of a statement. When statement is given, we have to say whether the statement is true or false. An element of a set can never be a subset of itself. An element of a set can never be a subset of itself. You just think over. We will discuss it in the next class. Thank you.